Okay, so we've got another question, 26 from the supplementary problems for equilibrium. Hydrogen and fluorine are gases. They're making hydrogen fluoride gas. And this is a very common setup. You're told how much reactants are in a container, 0.5 moles of each reactant in a 1 liter container. This is a little bit of a gift, isn't it, this question, because you need to switch to molarities. But if you forgot to switch to molarity here, it actually wouldn't matter, would it? Because 0.5 moles divided by 1 liter is still 0.5 molarity. So on a test, I would be more careful to make sure that it mattered if you forgot to switch to a molarity. Here, your numbers wouldn't change if you didn't switch to molarities, okay? At equilibrium, we're told the hydrogen concentration is 0.1 molarity, and we want to calculate Kc. So we've done a couple of examples of this. We know that you start with your balanced equation, H2 gas, fluorine gas makes 2HF gas. It told us initial and equilibrium information, so that's the clue that we're going to need an ice table. I think pretty much all the examples we've done so far have needed ice tables. Maybe we should do one that doesn't, just so you can see what the question looks like. You had 0.5 moles in a 1 liter vessel. So you remember you want to use the equation C equals N over V, where N is your moles and V is your volume in liters. So 0.5 moles in a 1 liter vessel. Tell me you're not picking up a calculator. That's 0.50 molarity, 0.50 molarity. It said of each reactant, so they're both 0.5 molarities. It didn't mention the HF in the container, so we'll assume that it's starting off at 0. And now we're told one other piece of information. The equilibrium concentration of the hydrogen is 0.10 molarity. Okay? I suggested yesterday that you might want to get in the habit when you're doing these problems of using one color of ink for the information that came from the problem, and then choosing a different color of ink for what you're going to figure out. When you read your problem later, you can distinguish what you were given from what you figured out yourself. So I'll do that. I'll use a different color of ink. What's the one thing I can calculate right now? H2. What the H2's change, right? If you began at 0.5 and you ended at 0.1, then clearly you lost, right? What's another reason, without looking at H2, what's another reason I should have known that the left side is losing and the right side is gaining? The initial HFs, that's right, was 0, so that had to gain. And if the products are gaining, then the other side of the reaction has to be losing. That's right. Okay? So this guy began at 0.5, ended at 0.1. He lost 0.40. Then how much does the fluorine lose? Why is it the same? You look at the coefficients, 1 hydrogen for every 1 fluorine. Because their coefficients are the same, they both lose the same amount. So 0.5 minus 0.4, this guy also ends at 0.1. And what about the HF? What does he gain? Twice that, because of the 2-to-1 ratio. So you can do it as just write down 0.8 if you want, but to help you remember where that came from, you might want to do that instead. Okay? So it ends with 0.8 molarity. You began with 0, you added 0.8, and at this point the question's really finished, isn't it? We want to calculate Kc. Kc will be the HF concentration, the product, squared. It has a coefficient of 2 in the balanced equation, divided by the hydrogen concentration times the fluorine concentration. Okay? Products on top, reactants on the bottom, equals 0.8 squared divided by 0.1. You could write 0.1 times 0.1 if you want, or 0.1 squared. Okay? Anybody can do that in their head? Ready? What's 8 times 8? Well, then what's 0.8 times 0.8? 0.64. And to divide by 0.1 is to divide by 1/10, isn't it? When you divide by 1/10, you're really multiplying by 10. So 0.64 divided by 0.1 is 0.64 times 10. That's 6.4. And then you do it again because it was 0.1 squared. So your answer is 64, isn't it? All right. Why is it so big? This is the first time we've seen a really large Kc value. Why is the Kc bigger than 1? We lost 80% of what we started with. You had 0.5, you lost 0.4, you gave up 80% of your reactants. So when you're losing most of your reactants, Kc should be larger. Okay? In this case, 64.